In this lesson, we're going to learn about proofs with special quadrilaterals. So just a reminder, when you're trying to prove a rhombus or a rectangle, you have three different strategies that you can use. So if you're trying to prove a rhombus, you can prove it by using the definition of a rhombus. So a quadrilateral with four congruent sides. So all sides are congruent. You could show that. The other two options are possible, but keep in mind that you have to first show that you have a parallelogram. So a parallelogram with perpendicular diagonals would make it a rhombus, or a parallelogram with two congruent consecutive sides would also make a rhombus. But you have to make sure for those that you show it's a parallelogram first. And then the other option, if you're trying to prove a rectangle, again, is to use the definition of a rectangle, so all four right angles, or you could prove a parallelogram and then prove one additional thing. So a parallelogram with one right angle would make a rectangle, or a parallelogram with congruent diagonals. So these are your different strategies for proving special quadrilaterals, so rhombuses and rectangles. So let's go ahead and look at an example. So the first thing here, we are given a parallelogram. We're given ABCD is a parallelogram. So that means since we're given it's a parallelogram, we can use any of the parallelogram properties, or we can state any of those parallelogram properties. And then we also have some perpendicular lines. We are trying to prove that it's a rectangle. So unlike a coordinate proof, you can just pick which one of these methods you want to use. When it's a Euclidean proof, we really have to use what's given to help us figure out one of these three things to then be able to prove it's a rectangle. It might be possible to use all three methods. It might be possible to only use one method. It all depends upon what's given to you. That's the beauty of coordinate proofs. You can pick what you want to do. So for this, let's go ahead and start writing down our givens and start making some conclusions. So we have ABCD is a parallelogram. So that's given. So that gives us a lot of information, actually. And then we have some perpendicular lines. So we have CE is perpendicular to EA, and BF is perpendicular to EA. And it looks as if my right angles here are already marked. I'm just going to move this down so it's not touching the picture. But my right angles are already marked with the perpendicular. So that is something I don't need to mark yet, but I'm probably going to have to mention those in a minute. So this is given. So our goal is to show that this right here is a rectangle. So if we can show we have four right angles, that would work. If we can show a parallelogram and then either show one right angle or a parallelogram with congruent diagonals, that would also work. So right away, I'm looking towards doing this method right here in the middle, because if I can prove that that quadrilateral here is a parallelogram, well, I can already see I have one right angle formed from the perpendicular lines. So I'm thinking if I can get that this is a parallelogram, well, then I'm done. I can just say it's a parallelogram with one right angle. So the question is, can we get that that's a parallelogram? Otherwise, maybe I could use that right angle and get this right angle, which wouldn't be too bad since we know that these are perpendicular. But could I then get these right angles? That's what I'm not sure about. So using the fact that this pink quadrilateral here is a parallelogram, I know right away that the opposite sides are parallel. So I know that these two sides are parallel, which happen to be the two sides of this purple quadrilateral. So that really tells me that CB is parallel to EF, which is good because that's one step closer to getting that that's a parallelogram as well. And then the other thing that I'm seeing here is since I have these perpendicular or these right angles and the perpendicular segments here, that means that since these angles are congruent because they're right angles, they're corresponding angles. Congruent corresponding angles would imply that these lines are parallel. So right away I can see that that purple figure is a parallelogram. And kind of going along with why these also have to be parallel, so there's two options. You can talk about the congruent corresponding angles because of the right angles, which form parallel lines. You could also say anytime you have one line that's perpendicular to two lines, that those two lines have to be parallel to each other. So anytime that is the case. So two lines that are perpendicular to the same line must be parallel to each other. So that's the quicker way of going about it. So really, I have everything I need. I just need to write it up. So my method that I'm gonna use, I'm just gonna make a note of this because these get a little bit more complicated. So my method is I'm gonna show a parallelogram first, and then I'm gonna show one right angle. So let's start with getting the parallelogram. So the first thing I said was I could say that those are parallel. So let's go ahead and mention that. So I can say CB is parallel to EA. So those entire lines are parallel. And that's because a parallelogram implies opposite sides are parallel. So that's getting me one piece that I need. And then the next thing we talked about was how do we get these parallel to each other? Well, the fact that I have two lines that are perpendicular to the same line makes those parallel to each other. So that's using this given right here. So now I can say that CE is parallel to BF. And that's because two lines perpendicular to the same line are parallel to each other. Or you could use that whole congruent corresponding angles giving you the parallel lines. And then now, since I have CB and EF are parallel and CE and BF are parallel, well, that's enough to say that I have a parallelogram. So now I can say, take these, put them together, and I can say ECBF is a parallelogram because if I have a quadrilateral, so a quad with both pairs of opposite sides parallel implies a parallelogram. So now I have this first part. I've proven that right here. So the only other thing I need to make this turn into a rectangle is I need a right angle. So I know that this right here is a parallelogram. So as long as it has a right angle, well, then that means it's going to also be a rectangle. And luckily, because I have the perpendicular, I had the right angle that was already drawn in. I do need to mention that in my proof. I need to say that angle E. So from here, I'm going to say angle E is a right angle because we had the perpendicular lines. So from the perpendicular given, we know that we have a right angle. So perpendicular lines imply right angles. That's how we get angle E as a right angle. And then from there, that's my right angle I need. So now I can conclude, so take these two, the right angle and the parallelogram, take those and say ECBF is a rectangle. And the reason for this is because a parallelogram, so make sure you mention the parallelogram because you have to have a parallelogram. So a parallelogram with one right angle implies a rectangle. So since I have the parallelogram, I proven, and I proved the right angle, that's how I can get my rectangle. So there you have it. So there's your proof. And remember, you might have been able to do this using one of the other methods, but this definitely was the most direct way. You could have also done using this method using other approaches. It didn't have to be proving the parallelogram using opposite sides parallel. There's other ways to do it. This is just the most efficient way that I found to do it. So go ahead and using these methods, go ahead and complete the check your understanding problem. So do your best with the proof and try to use one of these, use one of these methods up here and just try your best to get to one of these. Just be careful that if you're going to be using the second or third method, make sure you first prove it's a parallelogram. Okay, so do that, and then we will talk about that in class tomorrow.